My name is Sagar Mohite, and I work at Datadog as a data visualization engineer. Cameron here happens to be a colleague of mine, actually. And so my background, I come from a background of traditional computer science and traditional visual design. And at some point, it only made sense for me to merge my two interests. So I've always been fascinated by this idea of visualizing computational artifacts, as well as, sorry, you can see my slides, right? Okay. So I've always been fascinated by this idea of visualizing, computational artifacts, as well as the opposite, which is expressing quantitative nature of visual design. Uh, and that's why I sort of spent the last decade in doing things that concern with visualizing data and codifying visuals. Uh, More recently, though, this fascination of expressing as well as interpreting machine level information through visuals has sort of taken in different direction with the democratization and accessibility of machine learning in general. So if I have to draw on the back of a napkin what a machine learning model, or which is like a core process that empowers machine learning outputs, does, like, I would say that a machine learning model, generally speaking, consists of two pipelines. One is a training pipeline, and the other one is the classification pipeline. A training pipeline is basically us feeding data to the model and teaching it how to interpret and learn from that data. And a classification pipeline is us feeding new data and then asking it to classify the data based on the previous data um, that we trained it with. And in the back of the scenes, this is a very complicated process. And so up until now, like, as users of popular tech, we have interacted with like such models, with the, or rather with the output of such models in our everyday life, be it a Google search or a voice query or Gmail autocomplete. Like, every interaction we do has in some way created a feedback that either classifies our actions or trains models in the cloud. But as engineers, as developers of data visualization products, for example, like developing machine learning apps has required a level of niche expertise uh, that hasn't been super accessible up until now. But these days, with the accessibility, with the creation of tools like TensorFlow, OpenAI, CoreML, PyTorch, that has changed. And so naturally, like, designing visualizations, like, how can we take advantage of all these tools and technologies to empower the creation of data visualizations, or rather, how do we design and develop visualizations uh, and make the whole experience of designing and creating visualizations better with the power of machine learning, is what I have been recently focused on. And before much ado, I would like to go ahead and talk about this particular model called GPT-3, which is developed by OpenAI. And GPT stands for Generative Pre-trained Transformer. While it seems like a big term, what it actually means, I would just like you to focus on the pre-trained part. So this model has been trained with billions and billions of data sets, specifically text-based data sets. And this is also a text in, text out model. So we provided text and it gives us back text of some form. So one of the ways we can actually use this model, which has been trained with a diverse and large, enormous corpus of text from human history, is autocomplete. One of the first examples that the website, the documentation has is this sentence where you start typing a sentence and it completes. The green part here is the text that is generated by the machine learning model, and the white part is the text that was given as an input. And autocomplete has been, we've seen autocomplete in almost all instances of our lives, and every other company has their own sort of interpretation of this natural language-based text processing model. But like, how can we actually extrapolate this and use it for data viz prototyping? Was something that I wanted to explore. Now, when it comes to data viz prototyping, we're used to seeing autocomplete prompts in our, when it comes to programming in general, not just data viz, I would say. We're used to seeing autocomplete prompts in our browsers. So in our IDEs or code editors. So when I type something, I see a list of functions that are available to me to call. And so here are some math utilities, for example, that I could use when I'm writing a program that generates a visualization. But like, when we have this powerful, corpus of data powering our autocomplete engine, like building or specifically prototyping visualizations can actually be made much more powerful. So this prototyping process often involves making a lot of micro decisions that optimize the visual appeal of a visualization while also preserving the integrity and fidelity of the underlying data. And so that sort of art of balancing usually ends up in the developers going back and forth on several choices like colors, sizes, shapes, and text display. So I sort of wanted to experiment with like what happens if we let a machine learning based a GPT-3 trained model autocomplete our things. And in this example, I started with a pink palette, and I hit submit, and it returns me a set of colors. And it also, in this case, I had because it's a text-only model, I had a response length of 64 in here, which caps the response, the size of the response of the text that comes out. So in this case, it also ended up generating a blue palette for me. What is interesting is like some of these are actually pink, and well, most of these are actually pink. But what is interesting is if I actually add descriptive comments or descriptive variable names, the output changes. So like if I say pink sequential palette or pink diverging palette, the output will be mostly sequential or mostly diverging. And the reason I use the term mostly is because this is still a model that is trained on a large corpus of just English language and not specifically programs. And that's where teaching it custom layers on top of this natural language comes into play. So here's another example where I started writing a program that generates a bar chart, and it was interesting to see that it automatically generated like boilerplate D3 code that people have to write while writing a bar chart. So in this case, I'm trying to create a React.js component to draw a bar chart, and then I hit. So this is what I typed, and after I submit it, it sort of generated a data variable and created two scales. And if I keep hitting continue, it will start writing the program for me. And incidentally, this is all valid program that can actually be compiled to render a bar chart for us. And this is without any custom classification. But the good thing about this is like in order to build, because it is like GPT-3 is powered by this large diverse set of general purpose text, we can actually build layers on top of it for custom applications with relative ease. And all it needs is like a relatively small sample size of examples to train it to do some specific non-general purpose task. So for example, you can have like English to French translator, summarize a paragraph for a second grader, keyword extraction, movie to emoji, and so on. The nice thing about database and programming in general is that the data that we have, the millions of database programs that exist out in the open source worlds that generate bar charts or pie charts or any type of visualization that you can think of, are structured data. So, and oftentimes they're written with the effort of maximizing readability and with comments to document what they do. And that just means it's great. It's a great candidate for a natural language machine learning model to learn off of. So here I tried to write like 3 programs as an input, which basically just say, hey, render, this is how you render 1 bar chart, this is how you render 2 bar charts, this is how you render a bar chart and a circle chart. And then I sort of left a comment saying function to return an SVG data with 3 bar charts and 3 circles. It automatically named that component bar circle chart multi, and it started writing the data. I didn't paste the right screenshot with the completed it. This is an incomplete output because it has a 64 character limit selected while I was interacting with the API. But this is great. So this is like a great starting point. Like it can be a great tool to aid engineers in developing data visualizations rather than actually approaching a future where, you know, machines replace human beings. I don't think that's going to happen in a discrete fashion. It will always be like a gradual translation. That being said, like, what about design? Like, database also involves a lot of creative liberty and liberty taking, and like inherently is a creative process. So teaching machines how to generate creative outputs is, you know, I mean, it's no longer a fantasy. Like we have seen a lot of style transfer and creative output in the machine learning world recently. But without getting into the Turing test debates of whether the creativity of outputs generated by machine learning models is comparable to the creativity of, say, human designers, you could still argue that the creativity of machines is still at least equal to the summation of human creativity that we've trained the model with. And that in and of itself is a big reason for us to employ machine learning in the same fashion as we did for engineering for the design process. So we could potentially use it as a co-pilot for driving design decisions. Thankfully, we also have a lot of structured data available in the design space, design and product space when it comes to visualization. So this is like just a few images that I took from Peter Aldos's course, database course that he has, where he talks about, you know, what are the different types of shapes that you can use to express different types of meaning to the data. And at the same time, we have like different aspects of data that apply for different types of visualization. So for example, like relationships can be shown with a graph-based diagram. Distributions can be shown with a distribution scale, or which is sort of like an extension of a bar chart. Like comparisons can be used in many different ways, like circle packing or other terms. And so like having this sort of sequential guidelines can actually be used, is actually good for us to start training these natural language models or otherwise, just to sort of create this system where you can give the system a type of data set and tell it that you want to create a visualization that compares these values by proportion and these values by relativistic, by some sort of relativistic comparison scale. And then it can tell you, hey, this type of visualization is probably best suited, or like a combination of one or two types of visualizations are suited for your use case. And lastly, one of the cool things about this is that right now we saw like DOM structured text based visualizations like SVG can be used with, can be generated by a GPT-3 model. But what about canvas-based visualizations? Like in a similar manner, like text classification, there are many image classification models like MobileNet, for example, that can learn off of raster images and also create raster images. There are several models that can autocomplete your drawings. So if you start drawing, say, the image of a cat, they can fill it in with color appropriately. And lastly, like it is a reversible process. So if you can teach it how to draw a visualization from a set of text, you can also teach it to interpret a visualization, a visual diagram into text, convert a visual diagram into text, which is vastly important for things like accessibility, because visualizations by definition aren't accessible to people with visual impairments. And generating meaningful descriptions is very important in those situations. But yeah, that was my quick talk. You can access the OpenAI GPT-3 playground that I use to generate the examples here on the OpenAI beta website, which is taking registrations. I think there's a wait list though. Also, yeah, Datadog is hiring. So if there's any engineer who would like to contribute to DataViz at Datadog, feel free to reach out to me or Cameron. Yeah, any questions?
Any questions?
I have a comment. Just that this is really cool, and there's a lot of people like the R Forwards Foundation, and I've seen some tweets from Hadley Wickham at our studio, who's really interested in being able to auto-generate descriptions of, for example, ggplot visualizations. So, this is awesome. And if you want me to connect you with anyone, let me know, because I think they'd be really interested in this.
Cool, yeah, that would be great.
Other questions? Then the last thing he said was that Datadog is hiring, which reminded me that I usually start these sessions by asking whether anybody here is hiring. I also usually start by thanking Cameron for hosting us, and I certainly did not mean to imply that I don't really appreciate all that Datadog has done for our meetup. So Cameron, if you want to say a little in addition about hiring, and then if anybody else is hiring, please put your contact information in the chat so that people who are looking for jobs might know about it. Cameron, did you want to say a word or two about what Datadog is looking for in the way of hiring?
Not well. First, like I really enjoyed, I work with Sagar every day, and there's so many projects going on within the company. Like this isn't a core part of what we do every day, but we'd like to experiment with ideas like this. So if you found this interesting, and even if you're not fully engineering, but you're maybe closer to the product design side of things, we're also hiring for those roles on our team. Yeah, if I wanted to ask Sarah a follow-up. I was curious what the process of customizing this general model to make it specific for DataViz to prepare the examples for this talk. Are we talking like weeks of work or days of work? Like how much effort is it to customize this general model to be suitable for data viz demos?
So I think my guess is a couple. Well, in terms of, I don't know in terms of time, but in terms of the actual amount of data, I think one organization's code base would be enough of a starting point. Of one organization's code base of, say, a set of reusable database components would be enough of a starting point to sort of just get started in the right direction for building something like an autocomplete sidekick while programming. It will not be a general purpose, hey, give me a program for data visualization for, write me a program for building a data visualization with these parameters. So yeah, so that's my short answer, but I think it will involve like a lot of non-trivial work if we want to attain that future.
Yeah, that's awesome. It's heartening to hear that we don't need to like be like Google and have reCAPTCHAs and have people saying, oh, what kind of chart is this? And then people writing, oh, that's a pi or that's a parallel coordinates to get interesting results.
Yeah.
Cool.